Yeah, if you ever have that question, man, this is really too simple, it's probably wrong. Probably wrong. All right, so it says find dy over dx at x equals 1 for the equation y squared plus x equals 2xy. So when I need to find my derivative, right, because that's what they're asking for, dy over dx, and they gave me x equals 1, what am I missing? Y, right? So if I plug in x equals 1, I get y squared plus 1 equals 2y. And, all right, I'm going to move the 2y over. That gives me y squared minus 2y plus 1 equals 0. So if I factor it, that's going to give me what? Y minus 1 squared. So y would have to be what? Okay, good. All right, so our point now is 1, comma 1. That's the point that we are finding the tangent slope for, or the derivative at. All right, so just because they don't give you a piece of information doesn't mean you can't find it. All right, so derivative of y squared would be what? Okay. And then derivative of x is just 1. Now I have 2xy, so that means what rule do I need to use? Product rule, right? So you can leave the 2 on the outside if you want, and then you just have to remember to distribute him when you're done. And then you're going to be using the product rule around x times y. So you have derivative of the first times the second would be what? Y plus first times the derivative of the second, which would be what? All right, good. Okay, so that leaves me with 2y dy over dx plus 1 equals 2y plus 2x dy over dx. All right, because you had that 2 originally out here, and you just distribute it to both terms. Now what would you do? So this is the product rule using x times y as your function. So derivative of the first would be 1 times the second. That just gives you the y plus the first times the derivative of the second, which is just dy over dx. All right, so I'm going to move this over here and then move the 2x dy over dx to the other side. So you have 2y dy over dx minus 2x dy over dx equals 2y minus 1. Hi, how are you? She's nice. Not good, she's nice. I don't think I believe you. I don't think I believe you. Yeah. A little exhausted, yeah. No, he'd get up at like 6 and he'd just go run for 3 hours, and then. No, I think it was just Mr. Joyce. decision. Just the smells that were just coming out of that. No, I have my headphones in most of the time, so. Well, when you guys were watching Tropic Thunder, Mr. Joyce kept looking back at me like every time. It's such a stupid movie. Well, I've only seen bits and pieces of it, so I didn't really know what was gonna happen. I don't think he really sleeps. All right, so you divide the 2y minus 2x over, and you get your derivative. Now, I guess you could. It doesn't really help you, though. So it's asking us to find dy over dx at a particular point, and that point we found was 1, 1. So you have dy over dx at 1, 1. All right, so what I want you guys to get used to is writing it in this notation when you are evaluating, an implicit derivative. Get used to writing that bar and then the point, all right, because that'll give you points on your free response questions. All right, so I have 2y minus 1, so that's going to give me 2 minus 1. And then 2y minus 2x, so that's going to be 2 minus 2. And that means what? So what does that mean if your slope is undefined at a particular point? Not vertical asymptote, but no, you're right with the vertical, just not the asymptote part. Right. So you have a vertical tangent at 1, 1. All right, so anytime you are doing an implicit derivative and you get an undefined, this is telling you you have a vertical tangent at 1, 1. So a lot of these curves look like something like that. So you might have a vertical tangent line like right here. It kind of looks like that. All right, so that is one thing you guys need to remember. A lot of the times when they give you implicit problems, they're going to ask you where do you have a horizontal tangent line, where do you have a vertical tangent line, and then so on. So horizontal tangent is when your slope is 0, right? So you're going to get, what you want to look for is you want to look at the numerator and set the numerator equal to 0, and you want to make sure that your denominator does not equal 0. So you want 0 over some number. Okay, vertical tangent lines is when your slope is dne, or you get some number over 0. Okay, so a lot of times all you're going to have to do is kind of set the denominator now equal to 0 and make sure that you don't get 0 on the top. Because if you got 0 on the top, that would mean a horizontal tangent. And then if you get 0 on both, we know that that is a what? Right? What else do you know? When you get 0 to 0. Right? Really nothing. Like you're just that you don't have a horizontal or a tangent slope at that point. All right, so the graph of the equation x squared plus y squared is a circle centered at the origin with a radius of 4. No, you don't have to. All right, so you have your circle, right? And we know that this point here would be what? 4 what? Okay. And that point there would be what? And this point would be, and then this point would be, okay, so we are going to be figuring out information to that equation. So it says find dy over dx. So I have x squared plus y squared equals 4. All right. And you are finding the derivative with respect to x on both sides. So what would the left side? Well, when you take the derivative with respect to x, this is going to turn into dy over dx. Right. Good. It's the same thing. This is like the verb. This is telling you, okay, find the derivative, and then this is your answer. So this is like a noun. I hang out with an English teacher for way too long. Yeah. too much, yeah. Hanging out with an English teacher too long. And then the derivative of 4 would be 0. So you have 2y dy over dx is equal to negative 2x. And then dy over dx is equal to negative 2x over 2y. Or what? Negative x over y. Right. So we're going to probably use that for the rest of the problem. All right, and you got long hair, so you can use that too. It's a good hair gel. Okay, so it says verify that the graph has horizontal tangents at 0, 2 and 0, negative 2. Okay, so all right, so if it's asking us for horizontal tangents, that means which part of my derivative do I want to work with? The top part, right? So I need to set the top part equal to what? 0, right? So I want negative x is equal to 0, so x has to be 0. That was tough. So now you need to come up with the y values at that. So you have a horizontal tangent at x equals 0, right? So so we need the original equation now. And actually, we need to go back to that because we did something wrong. So your equation for a circle is x squared plus y squared equals r squared. So if it says it's equal to 4, your radius actually is what? 2. So all of these points are actually, instead of 4, 0, it is 2, 0. All right, so now those points are more accurate. Okay, so if we found that x was 0, right, we can just substitute that in. So we get y squared equals 4, so y would have to be plus or minus 2. All right, so your 2 points are 0 and 2, and then 0, negative 2. So when it says verify, you need to show that, by setting your derivative, right, in the top part of your derivative equal to 0, like that would give you 1 point. And then finding the x value would be 1 point, and then finding the y values would be probably another point. Right, yeah. So you need to find the derivative first. So find dy over dx. And then set numerator equal to 0. And then plug into the original. So you get the answer. All right, so verify that the graph has vertical tangents at 2, 0 and negative 2, 0. So again, we have dy over dx is negative x over y. And now what piece do I want to set to 0? The bottom, right? So y is equal to 0. So that makes x squared plus y squared equals 4. So x squared equals 4. So x is plus or minus 2. So that gives me 2, 0 and negative 2, 0. Which is what you want. So you have vertical tangent lines. So you want to set the denominator part equal to 0. So since we only have a single term, we don't have a lot of work to do. Yeah. Yeah. So if you got A long, you would be getting all. Well, would you still see like a 4 and 5? Like we're doing it right, just with a different equation. I might. College Board won't. I won't. I mean, I will, but College Board won't, so. Say again? Yeah. All right, so what values of x is the slope of the graph? 3 over 4. All right, so we figured out that dy over dx is equal to negative x over y. All right, and this is telling me that I have a slope of 3 over 4, correct? Yeah. So, what would the values of x be that are going to give me that? So x would have to be negative 3, and then y would have to be what? No, I think that's all you have to do. What values of x is the slope of the graph? 3 over 4. So if we figured out that x was negative 3, that would give me 9 plus y squared equals 4. Well, I'm trying to think, because it's got to be another point. 3 over 4. Because you're looking at your circle, right? And you have a slope of 3 over 4. So that could be like a slope of 3 over 4, and then the other point would have to be what did we figure out the first one was? It was negative 3, 4. So that would be somewhere kind of up here, right? And then the other one would have to be like what? So it would be 3, negative 4. You're right, that would not be on the line. Because you only have a radius of 2, right? So this would be kind of more out here, right? That's probably what it is. It's probably still using 4 as a radius. No. All right, so we're going to stop there for today. Pick up with number 6, mañana.